Hello everyone, we are going to see the sieves method for computing primes less than or equal to n in a time complexity of n log of n. So how does this sieves method work? So we initially make an array of our is prime of size n plus 1 to be precise. So we store the number n. So now we go from 2 to root n, and from, suppose this is I, this number, so we go from square of I till n to, and we mark them as not prime. For example, if we start from 2, so we start from square of 2, that is 4, so we mark this as not prime. Then we go to 6, not prime, not prime, not prime, not prime. We can delete this entire right column. Then we see for 3. Now for 3 we start from 9, so we 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. That's it. After that we go for 4, so we start from 16, 16, 20, 24. All of the 4s will be marked as not prime because we are already marked 2. So after that we go for 5, so we start from 25, 25, 30, 35, 40, 45, 50. Then for 6, and after we continue this, so after we continue this pattern, we'll see whichever numbers are left that are going to be prime. So this is really an efficient method to compute the number of primes, or the actual primes in 1 to n. So how can we code it? So we can initially mark less than or equal to n, mark is prime as true. Then we start from 2 and we go till square root of n. Now if we see that this is prime I, if we see that this is prime, then we go from its square I into I up to, let this be j less than or equal to n, and j plus equals to I, and we mark is prime of j to be false. And this is how we are left with a boolean array which will tell us whether a given number is prime or not. This is a simple code, and in this array we can store that a number is prime or not. Thank you.